Hello, I'm Patel, and I will be your guide for this presentation. If you have any questions throughout the presentation, please do email us because we would be glad to answer them. Our email is in the description below, or if you prefer, you can just comment, and we will reply very soon. Okay, let's begin. Today we will show you about a comparison of efficiency and benefits in calcium hydroxide and lithium hydroxide for reduction in carbon emissions. So, we are all aware of a common global problem on Earth. Carbon emissions. We as humans release billions of tons of carbon into the atmosphere annually. It causes a large variety of problems such as storms, tornadoes, and tsunamis, which destroy rich and diverse ecosystems. Glaciers melt, sea levels rise, marine life suffers, and even the natural geography suffers. Constant efforts have been made to solve this problem, but we believe that chemistry will be the path for the future. Both calcium hydroxide and lithium hydroxide have been proven to absorb carbon dioxide, but we have compared these two substances to see which one will be more effective when used in the real world. This meant for a long period of time we have done extensive research and calculations back and forth in order to make a conclusion. Our purpose. Now, why did we want to spend a large amount of time on this topic? We aim to discover an efficient chemical solution for carbon capture technology. CCT is a term described for the process of removing carbon gases from our atmosphere. Therefore, lithium hydroxide and calcium hydroxide have been assessed for this technology. The experimental process and conclusion that we have done will partly be useful for a larger application in the real world. The hypothesis. Okay, so on the left-hand side right here, there's a periodic table. And you can see that lithium is a part of the alkali metals, and the alkali metals are commonly known for their high reactivity, while calcium is a part of the alkali earth metals, which generally have a lower reactivity than the alkali metals. This idea led us to believe that the high reactivity of the chemical composition lithium hydroxide would cause it to rapidly absorb a larger amount of carbon dioxide than the less reactive calcium hydroxide. This slide shows an experimental calculation for lithium hydroxide. The scientific equation below represents for every 2 moles of lithium hydroxide, 1 mole of carbon dioxide can be absorbed. Now let's turn moles into a more easy and understandable unit of measurement, grams. So again, 2 moles of lithium hydroxide can absorb 1 mole of carbon dioxide, which is equivalent to, for every 47.90 grams of lithium hydroxide, 44.01 grams of carbon dioxide can be absorbed. Now let's go even further. For every 1 kilogram of lithium hydroxide, 918.79 grams of carbon dioxide can be absorbed. Now currently this seems as a good amount, but let's compare it to the experimental calculation of calcium hydroxide. Here are the experimental calculations for calcium hydroxide. If we look at the scientific equation below, it represents for every 1 mole of calcium hydroxide, 1 mole of carbon dioxide can be absorbed. Now let's turn moles into a more understandable unit of measurement, grams. 1 mole of calcium hydroxide being able to absorb 1 mole of carbon dioxide is equivalent to 74.09 grams of calcium hydroxide being able to absorb 44.01 grams of carbon dioxide. Now let's go even further into kilograms. For every 1 kilogram of calcium hydroxide, 594 grams of carbon dioxide can be absorbed. Now we determined that lithium hydroxide absorbs more carbon dioxide than calcium hydroxide. So everyone would say that it's reasonable to choose lithium hydroxide, right? But wait, again, this has to be considered as if it was applied in the real world. That is why we have to take the cost of each substance under consideration. So let's investigate that cost. Here's the cost and application for lithium hydroxide. For an example, the annual carbon emissions of a car is measured at 4.6 metric tons. This will be the basis for the comparison in cost. The calculations below show that if we wanted to remove 4.6 metric tons of carbon dioxide, $57,575.72 would be required. On the left-hand side here, a graph can be seen to represent the average cost of lithium hydroxide per kilogram, which is about $11.50. Now here is the cost and application for calcium hydroxide. Now if we wanted to remove the same amount of 4.6 metric tons of carbon dioxide with calcium hydroxide, it would approximately cost us $157,205.43. On the left there is a graph which represents the average cost of calcium hydroxide per kilogram, which is about $20.30. In chemical efficiency and in cost efficiency, lithium hydroxide performs better than calcium hydroxide. However, in practical use, neither of these substances will be effective. It is simply not practical to spend approximately $60,000 to remove the amount of carbon emitted from cars annually. Another scientific method must be conducted in the future to reduce cost or even find an alternative way based on our work. This experiment explained to us that currently, lithium hydroxide and calcium hydroxide will not be practical. And here are the sources that we have referenced. We would like to thank you for your time, and again, please reach out to us if you have any questions or would like to comment us for our presentation. We would be more than glad to hear from you. Thank you.